In this video, we're going to look at a mechanics problem focused around Newton's laws. So pause the video now and try all parts of this question. So this question is, or at least the first part is pretty standard. It's just reciting Newton's laws. So the first law of motion is all about the fact that an object will remain at rest or travelling at a constant velocity. And a constant velocity can, of course, mean a velocity of 0, unless there is a resultant, or you can say net, force acting on it. And of course, the tendency of objects to remain doing what they're doing, remain travelling at the speed they're travelling at, is of course called inertia. Newton's third law now suggests that forces always act in pairs. Which way are these forces in a pair identical? Well, they are the same type of force. So, for example, two reaction forces, two contact forces, or two forces of gravity, for example, and they are of the same magnitude. So Newton's third law, of course, being for every force there is an equal and opposite reaction. Which way are they different? So importantly, they act in opposite directions. All right, because one is acting on one object, the other is acting on the other object, which obviously then tells us that they act on different objects. If they'd asked for Newton's second law, then you would write out the equation force's rate of change of momentum in words or as a formula, but defining all the symbols. That's the second law. Okay, the second part of this question moves on to a projectiles question. So pause the video now and try all parts of this question. Part I of this question asks us to show that the rate at which the water is ejected from the nozzle is equal to this number here. So it's asking for the change in mass in 1 second. So what is this going to be equal to? Well, it's obviously going to be equal to the mass of water in a second. That's just restating what I've written as a formula. And what is the mass of water going to be? It's going to be the density times the volume of water, and then that is going to be every second. So this is one way of thinking about it: the density times the area times the length per second. Or we could think of it as density times the area times the velocity of the water. Why are these things equivalent? Well, what is velocity? Velocity is obviously meters per second. So that is effectively the amount of water that comes out. This amount of water that comes out in 1 second, which obviously is going to be equal to the length. So these two things are equivalent. So you can either think of it in terms of this, or you can think of it in terms of purely geometry. Either way, we plug in the numbers, and obviously there's a big clue. It's going to be to do with the area, because we've been given that. We've been given the density, and we've obviously been given the velocity. And we get an answer of 8.25 kilogram per second. So, and that obviously rounds to 8.3 to one significant figure. So this is a really nice question because it's really getting you to think about the units, and you can figure it all out from the units. Part II now says determine the vertical component of the force exerted by the ground on the fireman's feet. It's really easy here to make a mistake. And not get the full mark. So it wants this force here. So what's this going to be equal to? This is going to be equal to the two downwards forces. What are the two downwards forces? Well, we've got one force, which is obvious. That's the weight of the fireman. And then the other force is to do with this water here. So there is obviously a force of the fireman this way, and the reaction force this way, because the water is exerting a force backwards and the fireman has to exert a force forwards to keep it stationary. So therefore there is this vertical component as well. So firstly, we need the vertical components of the water, which is going to be what? Well, it's going to be 8.25 meters per second. I'm taking this number here. You could obviously use 8.3 if you wanted, times by 25 sine 55 degrees. So why is it this equation? Well, this equation is simply saying that it's the mass of the water times by the velocity of water. Well, it's actually the mass per second, but we're thinking about 1 second here. That is obviously the momentum, and the momentum, or the change in momentum, is equal to force times time. So we're finding the change in momentum, and we're saying in 1 second that is the force. So this force from the water is 169 newtons. It's actually quite a hard thing to realise, I think, and it's only worth 3 marks, but it is quite a challenging concept. What is the weight of the fireman? That's obviously mass times gravity. The mass of the fireman is 92 kilograms. Obviously, that's given in the question here. And gravity is 9.8. So therefore, the total force is going to be equal to both of these things added together. So that's 903 newtons. So the total force is 169 plus 903, which equals 1,100 newtons.